we are going to just right now show the combination of these two translations. Both of these are translations. If a number is added inside with the function itself, inside the function where you're squaring it, then it's one that moves it left or right, the opposite of what you think. If it's outside, it moves it up or down just exactly by its positive, it goes up, negative, it goes down. So in this one, the basic function for y equals x squared looks like this. It always goes through 1, 1, and then it always goes through 2, 4 for both sides. Okay, so that's as much as you really need to have for the basic function. So on your assignment, when I ask you, I'm going to ask you to do the basic function and then label it. Okay, so on this one, you would graph that basic function, y equals x squared. The main points would basically be 0. When you go to ones, they are ones. Both -1, +1 is 1. Positive and -2 are 4. That's far enough, as far as I'm concerned, to put the points on. Okay. Now, the new one, we're looking at it. If we look at this, we have inside the function a +1. What is that going to do?
To
what
the left
translation? One. Yes. It's going to move it left. Okay, so that's what that number does right there. What does the -2 do to the function? It moves it down 2. So when you're doing these, I want to see that written, okay? So I at least know you're pulling off the information correctly. You may graph it wrong, but at least they know you pulled the information off correctly. You meant to do it correctly, okay? So that means, and what I normally do is I just take the 0, 0, because it's the easiest one, and move it. So that says move it to the left 1 and down 2. So my new graph is going to be left 1, down 2. That is going to be my new point for 0, 0. I can do the same thing for this point. To the left 1, down 2. This one to the left 1, down 2. And basically, I'm going to get a function that looks like that. Luke, you see how you're supposed to be doing it? I am then going to label this problem or that equation with that graph with its proper equation. So if you were to do a problem, I just showed you how to do a problem on your homework, that's what you're going to do. Basically, I will give you a basic function. I will give you a new function. You graph the basic function. You tell me what it's going to do, the translation that's happening, and you move the function. Okay, label the 2 and you are done with that problem. Okay, so that's all you have to do on those. Some will have just one translation, one direction. Some will have 2 translations. That's okay, what you're going to look at. Okay, so now the only last thing I need to show you is what is the reflection over the x-axis. There's a way we can reflect all of these over the x-axis. And it's easiest to show with the quadratic. Okay, it's very easy to show with the quadratic. So when you take your basic function, this black one, now I'm going to get a different color so we can see it in a different color. The way we do a reflection around the x-axis. So this is a reflection around the x-axis. axis. Now, if you think about it, when we reflect it, what is it going to do? It's going to point down, right? It's going to be the upside down U. Does anybody remember how we knew if it was going to point up or point down from algebra?
To my brain. I'm like, I know what you're talking about.
Okay, so your basic function is y equals x squared, basic. The only thing you have to do to make it flip over the x-axis, to flip down, is you put a negative sign in front. Okay, so the new function will be y equals negative x squared. This negative right here, that signifies to reflect over the x-axis or in the negative direction. If it's been moved, you move it first and then reflect it right at that point, at the 0, 0 point. You can do it several ways. You can reflect first and then move, or you can move and then reflect. It works the same way. Okay. So in this case, my new equation will go down like this. And this is y equals negative x squared. Okay. So anytime you see a negative in front of the function, it means it's going to go down. Okay. Now, I'm going to just talk a little bit about this. If you have y equals negative absolute value of x, basically, here's your normal value x. Your new reflection will look like that. Okay? So this is y equals absolute value of x. This is y equals negative absolute value of x. That negative didn't get in there very nice. But that negative reflects it, the basic function, around the x-axis. Okay? Now, if it's translated, it's probably best to do the reflection first and then translate. Okay? And so, or you can do the translation, but then the reflection comes around where the vertex is. Okay? It flips it upside down from what it normally would be. Okay? So that's how we do a reflection. The negative in front of the function makes it a reflection. Okay? So if I had y equals 2 to the x power, okay, that basic function comes up, goes like this. If I don't put it in parentheses though, this is y equals 2 to the x. To do the opposite of that, I can't draw very well, like this is y equals negative 2 to the x. So that's, thank you for that. That reflects it over like that. So again, anything, but if I put it in parentheses, that does not make it like that. Okay, that does not put it there. Okay. If you're putting something in this function to move it, let me just show you that for a minute, because I think it's important. So, what we know is a number inside the function moves it left or right. A number outside the function added to it moves it up or down. The negative sign in front of the function reflects it. Okay? So those are the three basic ones. Tomorrow we'll talk about the inverse where it rotates it 90 degrees. And we'll look at that. If I'm doing it, I just want to really quickly show you this. if I have y equals 2 to the x minus 3 with parentheses around that, what is that negative 3 going to do? Think back to what we just talked about. What is that negative 3 going to do to the function?
Is it gonna move it down?
It's going to move it down or up or left or right?
It's gonna move it right.
It's going to move it right. Notice the 3 is in with the x. If it's in with the x, kind of like in parentheses with the x, it's going to move it left or right. Okay. In this case, it's going to move it right. So my basic function, like that, is basically going to be moved over this way. Okay. So many. That was a real estimation, but it's going to be moved over to the right. So, okay. So that's, I just want you to realize when the x is in there. Now linear functions are a lot harder because how do we we'd have to go y equals x minus 3 plus 4, which we don't usually write it like that, do we? Okay. We don't normally write it like that. This tells me move it up 4. This tells me move it over 3. But usually what we would write instead is y equals x plus 1. It really does the same thing as moving it up 1. Because if I move it up 4 and to the right 3, that's the same as moving it 1 up. Okay, which is kind of a weird thought. You can try it on your paper and see. Actually, let's just do it really quick. Okay. So here's my base function. Oops. That is not my base function. So this is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. This is y equals x. That's my base linear function. Okay. If I moved it up 1, that would be right here, and I draw it parallel. If I took it and moved it over 4, over 3, 1, 2, 3, and up 4, 1, 2, 3, 4, I would end up hopefully right about there. Be the same thing, same line. So if I moved it over 3, up 4, my line is not drawn straight, but if you do that on paper, they will end up being the same line. So we don't normally see functions as linear functions with something inside because the x is just by itself. And when I add a number or put it in parentheses and subtract it, we can actually put those together and it gives me the same answer. So it's just going to be reduced down. So that's something I want you to see just because we don't see them like this normally. Okay, so it's not going to have you. Most of the time, the only thing we're going to see is up or down. Because it's always going to go through the x and y axis somewhere. Our line will always go through the x or the y-intercept somewhere. Okay, and we can just simplify it to get where it goes through. Okay, so that's basically how it works. Linear is not as easy to show translations on. That's why we normally don't teach translations until you get past the linear functions because they're not very easy to see. Okay, and what is the opposite? How do I flip this? Well, that's y equals negative x. Okay. Well, that's going to be this one, and we are just going to flip it going this way. Hence, a negative slope goes down. Okay, this is y equals negative x. Because it flipped, if you noticed, I took this part and I flipped it. Oh my gosh, now this is really hard for me to see. I just know that's correct. Let's see. I flipped that over there and this over here, and that's what you get. Okay, that's y equals negative x. So that's basically the whole thing about translations and stuff. So I'm going to give you two things. One you can look online for. The other you're gonna have here. So I'm gonna give you some base functions and some new functions, and you are to graph them just like I showed you in that first one. I gave you the instructions on how to do that. So here are your equations. Here's my base. I'm gonna just call it B and N, so it's easier. So you get y equals x squared. You have y equals x plus 2 squared. Base function, new function. So this is problem 1. So write these down. It's also going to be on the video. So if you need to go back and check. You can also take pictures when I'm done if you want. The other base function. Oh, we'll do a cubic gets per ton. Oops. B and B. That'll get you some practice. So for those 6 problems, I'd like you to have those brought back tomorrow. Okay. On each of these, again, graph the base function. Then tell me what the translation is. Then do the translation and graph it. Label both of those. Okay. Label each equation or each graph with the proper equation on it, just like I did as an example. You can take pictures of that right now. It will also be on the video because I'm letting it just sit there right now on the video. So you can see it on the video also. So you have plenty of ways to know those problems.
So much stuff to do.
Okay, you can start right now if you would like. We're going to talk about the reflection or rotation tomorrow.
On one paper.
Want me to do